Welcome everybody to the digital workshop called Using Built-in Kubernetes Controls to Secure Your Applications. So with that, we can jump into the content. I'm excited to be here today. So overall, what we're going to talk about today is some of the building blocks of Kubernetes to sort of catch up folks who may not understand everything about what we're talking about. The typical security posture of Kubernetes clusters and apps. So that's sort of background material. Then we'll spend most of our time today doing exercises of how specific security controls on your workloads and in your cluster work live in a cluster that you can use. And in conclusion, we'll talk about how to adopt those controls while keeping the peace and not losing any friends. So that's the outline. We can start before that with let's get to know each other. So I've given this workshop live before, and unfortunately, we can't do that these days. But let's get to know each other a little bit. First, I'm me. I'm Connor. I am a product manager. I work at StackRox. And I used to be an engineer, so that's kind of my lens of the world. And in terms of Kubernetes, I sort of stumbled into that in 2015. At one company, figured we should bring it in there, and then moved to StackRox to start building container Kubernetes security products after that. Now I'd like to know something about everyone who's taken their time to show up. So Debbie has some poll questions that she can put out. So first, just sort of what best describes your role? Mostly looking for, are you primarily a developer? Are you primarily working in security? Are you working in operations? That kind of consultant vendor role. That's helpful for us to know before we continue. Maybe a few more seconds there to pick the right option. You should see the poll window showing up on your screen. Okay, and as we get enough responses, we'll be able to close out this question and move to the next one. Okay, so it looks like we have a primarily security-oriented audience, but a good mix of folks between building applications, securing them, operating clusters, consulting with others, and being a vendor. So thanks for answering that question. We can move on to the next question now, which is more about Kubernetes. So do you use Kubernetes at work? We'll have folks who come to these sorts of events who do all the time and are looking for more information, and also folks who are brand new to it. Does your organization use Kubernetes, or do you use it in your work? As we get enough responses, we'll be able to close this poll and move on. There are just a few more. This will help me tune some of the explanation as we continue. Okay, so it looks like we have mostly yeses, and then a good even mix of using Kubernetes every so often, sometimes and most of the time. Thanks for sharing that. Now we can move on to the next question. And sort of a different spin. What's your personal level of familiarity with Kubernetes? Separate from work, maybe. So if you maybe know what a kubectl, kubectl command does, or if you're deployed an app once or twice, that will help us make sure that everyone can stay on the same page. And again, we'll be able to close this as enough responses come in. Okay, nice. I'm glad to see that we have a good mix similar to the previous question. And just two more to finish up, which is more about your organization. So you might use Kubernetes a lot, but your organization might not. So we're just looking for how much does your organization use Kubernetes? And this one I think is a multiple select. I'm not sure, but can help us understand where you fit in your organization. Okay, and see that a lot of organizations are learning, and some are in prod, which makes sense. If you're in prod, you are a little bit forward-leaning, and that's always fun to see. All right, we can move on to the last question, and then we'll get started. This final one will help me understand kind of which security angles that would be most interesting to folks here. So the kinds of things that you're most interested in from a Kubernetes security perspective for your organization primarily. And with this one, we'll be able to close it as soon as we have enough responses as well, before we begin the building blocks and get into the exercises. Great, and it looks like we have a lot of folks interested in vulnerability management. You'll see a little bit of that in the first few exercises. In terms of configuration management, network segmentation, threat detection kind of stuff, you'll see a little bit more toward the end. And that'll be a nice mix of audiences for us to deal with through the exercises. So thank you for taking the time to answer those polls. It is really helpful for me to know a little bit about who's here and what gets you guys going, what gets you folks going. Okay, so we're done with the polls. It was nice to learn a little bit about the audience, and we can jump right into the orientation, the building blocks of Kubernetes. So if we talk about Kubernetes, often the first thing that comes up in people's mind is containers, right? So you hear about this Kubernetes thing, people say, oh, you use containers, cool, got it. And that's true, right? Obviously, Kubernetes is a container orchestrator. But I like to start when I'm explaining Kubernetes to someone who doesn't know about it. I would start one level earlier with images. And images are pretty neat because they're a standard form that we can use throughout all of our container infrastructure, and especially in Kubernetes, as a sort of cookie cutter for all of our applications. Because the image defines what software is going to be there, what the file system will look like, some of the defaults. I just reproduced here the Nginx Docker Hub official library image. You can see a lot of stuff in it. If you've never sort of really dug into a Docker file or especially looked at one from an official library image, it can be actually kind of interesting to see all the stuff that you can put into the image. So we see right off the bat like what OS distribution we're coming from and which variant of the version and which variant of the image we're going to take. We see some labels about maybe who's responsible for this image, some environment variables that are pretty important about what we're going to be putting into this image. Exactly how it was built, every single command that went into building this image. We see a file system changes to link standard out and standard error to some log file links, an exposed port, how we like the application to be signaled to stop, and the command that it will run when it runs by default. So that's a lot of information that just gets packed up in this nice standard format. And the other really neat thing about images is that since Docker 1.10 or so, we've had SHA-256 digests of all these images. So when you see an image running in production or running in a cluster and you have it on your machine, you can compare the two very well because it's got a hash. That's really neat also because you can go request that same hash from the registry as well. And since security is often kind of a data join problem, putting data between different systems and a configuration problem of locking down all the right configurations, this actually is a really nice building block for us to use for security. Then we go back to containers. Just check one thing here. Okay. So once we get to containers, containers, obviously aren't brand new. At this point, they're almost passé. Docker was popular since what, 2014 or so, and before that, it wasn't even a Docker wasn't itself even new. It used a lot of things from Linux, C groups, namespaces, file systems. But the container, people sometimes think of as a security box or something. Let's think of it more as a shipping container, something that runs everywhere that you can use to deploy your app consistently in different places. You can put a shipping container on a truck, you can put it on a train, you can put it on a ship, and it will run more or less the same way. And the other, just to underscore this, Julia Evans makes these wonderful comics. One of those there shows you just like a container isn't magic. Like it's not a magical security box into which you can put malware and run it and it'll be fine. You can see that actually you can do your own little version of a container in a couple lines of shell, creating C groups, making a file system, unsharing mounts, changing root into this little volume. And this is just to underscore that shipping containers, or the containers are more like shipping containers. They're not like lockboxes or vaults. But they're very useful, obviously, because they provide a sort of isolated environment for us to run our applications. It's a predictable, reproducible one. We can move on to orchestrators. So orchestrators, obviously, if you're here for a Kubernetes control, workshop, you've heard of Kubernetes probably. I noticed in the poll some of you aren't using it or haven't used it before. So the gist here is once you start running containers at any kind of scale, you need a lot of things for your application to go right. You don't want to just have one container running somewhere and forget about it. Because it will go down, it will need more storage, it will need to get rescheduled, some maintenance will happen, and Kubernetes handles a lot of those tasks for you. Sort of stands in the middle, making sure that the storage comes in when it's needed, the scaling happens when it needs to happen, that the network exposure continues working, that the application is still up when you need it to be up, that the secrets are provided, and then any sort of other interactions are mediated. And that's why we have a lot of orchestrators come up, and then OpenShift and Kubernetes are sort of the most prevalent these days, but you had other ones as well in the past. And the other key building block, I think, that all these things enable. So once you have containers, you have images, you have orchestration, you end up with standard APIs for basically everything. And that's actually how we at StackRox think of the world a lot, is in terms of this Kubernetes deployment. You can see that at the middle of this graphic. You can see all the information that comes around it, including the image. So all the vulnerabilities that are inside of an image, all the registry that it came from, the packages that are installed, both from the OS, from the language level dependency managers. You can think about your deployment in terms of where it is, which kind of cluster it's in. Is that run by a certain business unit? Is it a test cluster? Is it a prod cluster? Kubernetes provides annotations and labels, which let you tag on resources very well to help you understand what things are. There's a lot of granular control of privileges, which we'll see in the exercises, including like Linux host privileges, host mounts, Kubernetes service accounts, access to secrets, disks, things like that, and networking as well. So within and without of the cluster. So between applications and also with the outside. And finally, runtime behavior is often best understood in the context of the whole deployment, with all the context that you know from all those other things. So this is a really neat opportunity for security. And with all the options that Kubernetes provides that we'll see, you have a lot of opportunity to lock down your applications more than you might have before, or in a more visible way than you might have before. And finally, the last kind of key thing I like to mention, especially if folks are not as familiar with Kubernetes itself, is sort of your model for how you do things. And we throw in these almost buzzwordy things, but they're actually helpful. So it's declarative, immutable infrastructure. And that's maybe best understood as a contrast between imperative and mutable. So declarative and imperative, you can go back to sort of middle school grammar. Declarative is saying something, and imperative is saying to do something. So declarative, you can just say, I want this to be true. And you tell the Kubernetes API server, and you do this in the form of a YAML, as you see on the screen. Sometimes with a lot of YAMLs, more YAMLs than you might like to see. But then after that, it's immutable. It's not mutable. So you don't change it. You don't go and change the running applications. You just make a different request of what you'd like to be true. And this is also really powerful. And it really, you'll see this a few times in each of the exercises. We'll deploy something, then we'll come up with a new manifest, a new YAML spec that says a different thing, and then we'll deploy that to roll out a security change. There's no more going in and patching things or going and marking something read-only or something like that. And that's really a powerful way to do security in a way that doesn't either drift out of your desired configuration or cause you to lose a hold of what's actually going on in the cluster. So those are the building blocks that I always like to cover. Now we can talk a little bit about the typical security posture of a Kubernetes cluster. There's wide variety of thoughts on how these things usually work and how secure Kubernetes is, maybe out of the box or anything. So one good way to start is just to think about Kubernetes defaults themselves. So there are some good things, and there are some iffy things. This is a conversation that you might have stumbled into if you've been around in the community about how we might be able to change defaults or work toward a more secure by default distribution of Kubernetes. But out of the box, Kubernetes has some good things. There's no external exposure of services. So if you run a container, it's not by default exposed outside. It cuts off a lot of accidental exposures. And then immutability is encouraged. So it's easiest to use Kubernetes if you're sort of playing by the rules and using the YAMLs, and it's a little bit more complicated if you're trying to mess with things once they're deployed. So those are good things. But the things that make you think a little bit more and that make people sort of think Kubernetes doesn't have a great security posture is some of these other defaults where containers will run as root by default, and almost everyone doesn't remap root. So you're running as root on the host in every container by default. With network policies, any pod can talk to any other one. Containers will come with a writable root file system. So by default, they're sort of in a writable sandbox, and no seccomp applied. That feature's just starting to move again. But right now, in most places, you'll see seccomp actually, they take the Docker default and then get rid of it and go even more permissive in most Kubernetes distributions. And just to underline this, from the Kubernetes security assessment from last August, I believe, the assessors wrote that configuration and deployment of Kubernetes is non-trivial. Certain components having confusing default settings, missing operational controls, and implicitly defined security controls. So the implicitly defined things here is when we have either some environmental characteristic about the host or about the cluster, and it interacts with the YAML in some unpredictable way. So by default, we're not necessarily in a great place if you haven't spent some time to take the defaults and knock them down. And so you might then ask, like, are they typical? And the answer is like, yes, actually. I'm not sure that I've seen many clusters that I walked into that have anything but the defaults for many of those options. Although people did kind of wake up to root users when the run CCD came out about a year and a half ago. And are people better than this, you think? Well, some are, yes. And some people are sort of on the hill getting better, but some aren't as well. Most people aren't. And some examples, you might have heard about some of these. So often you'll see Kubernetes dashboards exposed. My colleague Karen, who's here helping, has been following the cloud providers and where their dashboards are enabled or disabled, they're supported or unsupported. And there's some good movement there. The Shopify Bugbounty on HackerOne is really worth reading if you want to learn about how pods can be used to abuse infrastructure. We have an exercise that goes toward that. A friend of mine was still running without RBAC in 2019. Haven't caught up with him in 2020, but this might be a problem for our friendship. And then, you see most containers running as root in most places, and network policies usually aren't there because they're a little bit difficult to get started with. So the situation is not necessarily good, but let's talk about how some of these things can get better. So if you too long didn't read or too long didn't listen, I guess, most people aren't great at this yet, but you don't have to be most people. And I hope that the exercises will, get us a little bit closer for you. So let's get into those. So we're going to do this using a website because there's a lot of copy paste and looking at things that don't fit well with slides. The website is there, secureK8s.dev, secureK8s.dev, and there are some setup instructions. Honestly, if you don't have a cluster ready, it may be a little bit late to start. But the first exercise page is a setup page that explains some of the requirements for what we'll do. For each of the exercises, we'll talk about kind of which control we're looking at. We'll run an application and then attack or abuse it in some way. So using the privilege that it has or using the exposure that it offers. At that point, if there are questions that have accumulated, I will answer them then. And then we'll apply a patch, talk about what that is, and then try the attack again, see that it doesn't work. And then we can take questions then again. So that would be using the Q&A at the bottom if you're interested in asking a question during those exercises. In terms of other logistics, do use a cluster that you're specifically allowed to run vulnerable apps in. Please know that we are introducing vulnerabilities into the cluster on purpose. So don't do that in the cluster. You're not supposed to do that too. And do think of other stuff you could do during the attack phase. So some of the exercises will have a place where we say like, okay, now we have host access. Like what dastardly things could you do? And you're welcome to submit those in the Q&A, and we'll share some of those if they come in. Trying to preserve some of the fun interaction of a live workshop. Don't use a cluster that hosts real workloads, or that you're not specifically allowed to run stuff in, and don't attack anything outside your cluster. Just concentrate on the apps that we're deploying. And we can answer general questions using the Q&A box about sort of what did you just do, or what is this kubectl apply thing that's happening, where are these images coming from, etc. But we can't actually provide individualized support or debugging just because of the format and because of the number of folks here. I will go through everything in case something doesn't work for you. So if you're in an exercise and it doesn't seem to be working for you, I'll be showing the exact same thing that you will be doing. So feel free to just sort of step back there. There are a couple poll questions we have here just to get a sense of who's going to be, coming along with us through the exercises. So we can answer a couple quick poll questions here, just to make sure we all know, make sure that we're aware. So the first question is, do you plan to run the exercises along with us? That's yes all, yes some, or no. This will help us understand, what's going to be going on your side of this event. Help with pacing and such. And we'll be able to close this once we get a reasonable number of responses. There's your best guess of, are you planning to run the exercise? Okay, we'll need to close this out shortly. Okay, looks like most people are going to come on, which is fun. So I'm glad that's true. And then the next question is going to be which kind of cluster you've got, just so I can make sure that I explain what's going on here. This is for the environment that you're going to use for the workshop. So I'll be using Google Kubernetes Engine. I've also run these on Docker for Mac. There are a couple other options here, obviously, though. And they all will have somewhat different interactions with some of the exercises. On the previous question, I did want to say also that if you're planning to just watch, that's also super cool. And I'm also glad you're here. So I don't want to imply that there's anything less about that. Okay, so once folks know what cluster they've got, let's see. Okay, so it looks like we've got a lot of Minikube, one Docker for Mac, one Docker for Windows, a couple of GKE and EKS, a couple self-managed, and a couple other. Okay, so we'll have a few exercises that have some environmental constraints. Primarily, those will be around like network policies or specific RBAC things where the example might not look the same, but we should be good with that kind of environment that I see here. Okay, so it's time for that exercises. So if you've landed on the webpage, securekids.dev, you'll see a link to the exercises also at the top. The setup, like I mentioned, will show you a little bit, tell you a little bit about the requirements. There's one thing I want to show here first before we get going. So some of them will use network policies. You can just skip that if your cluster doesn't support it. For some example, GKE, you'd have to use an option. The examples by default also use node port services, largely for simplicity across that number of environments. In some places, you'll have to make a firewall rule. So for my cluster, I had to make a firewall rule that allows this port range 31300 to 31305 to my machine. If you can't, you can create port forwards, but I unfortunately won't be able to show you how to do that. online. And some of them will be redeploying pods, so you'll just have to restart them after we replace pods with different configurations. So that's just letting you know. We've talked about being responsible. You can clone a repository if you want to see the scripts and stuff in your terminal, but you'll also see everything on the screen and in the website. So that's all you need to do. So to be able to do the exercises without modifying them, we'll be using node ports. If you are using a local setup like Docker for Mac, localhost might work. That'll be the default. What we'll use is this same environment variable for each of the attacks that require network access. So if you have Docker for Mac, there is one or two of you, or I'm not sure if Minikube will work on localhost. You'll be fine with localhost. If you're using a different cluster like I am, you'll have to just export, workshop node IP, and then I'll set it to the node IP that I have here. I got, oops, don't get it from Chrome. You can get it from kubectl get nodes wide. There's an external IP for my cluster. And then there's a little smoke test here if you want to just try and make sure things are working. This will deploy like an Nginx service, and then you can see if it comes up. So I'll open a little tab here. Once it deploys, okay. So if you have run the kubectl or create here for the smoke test, and then open that port 31300 on your node IP, you should be able to load this Nginx default page. And if you do, then you're ready to go. You may have to add a firewall. So I'm going to get started. If you have any trouble with a certain exercise, you can ask a question in the Q&A box, but we'll try to keep this rolling for to keep us in time. So we'll answer any questions as they come up. But if you get stuck and want to just watch, that's also totally cool. So we talked earlier about streamlined images, or we talked about images and how they're a really useful thing for security because you've got these digests and you've got all kinds of information about how the app will work when it comes up. So we're going to start with a vulnerable application, attack it, and then see how we can streamline the image to help out with our security posture. So we can see kind of the Docker file here. It's in the site, so you don't have to download it yourself. This is copied from a vulnerable image repository, and you can see that it sort of just starts with Tomcat and puts it in a vulnerable application and exposes it. So now in our cluster, we can go ahead and deploy the application. So we're using kubectl apply. What it does is take the manifest that I've given as a URL from this website, and it deploys it into your cluster. So it's made a namespace, it's made a new application, a deployment, and it's created a service so that we can access it. We can wait for it to deploy. It may take a second to download the image, especially if you're not running in the cloud or in the data center. So you're ready to move on once you see running here. And then we can Control-C out of that command. Then we can use a canned exploit to just exploit this application because it's got a struts vulnerability. It's a vulnerability in the Java Apache struts framework. You can see this is actually the injection. It's a big long injected I think OGML or something, some kind of funky injection. But you can see actually right here is where we have the exploit. So if you do all this funky stuff to this application, you can use this shell, and it will run this shell inside the pod. And with our sort of out of the box vulnerable no security lockdown container, we're able to just go ahead and download a crypto miner, untar it into the file system and make it executable, and then run it. And I've black holed it so it doesn't actually mine any real cryptocurrency. I should have made that mine, but Sorry. And then we can see that when we check processes inside the container that we see minor-ds running. So like the injection worked out of the box. We were able to download code, start running it in your application with an application vulnerability. And that's often how these things go if people haven't taken any steps to prevent that. So the first kind of countermeasure we can talk about is streamlining the image. You can see that this thing used a shell, it used wget, it used tar, chmod, and then ran the crypto miner. So we can make this image a little cleaner, and that might stymie the people that are out there, running scripts against all the struts applications they can find. This won't, stop everything, but it does make life harder for automated attackers, and that can protect you from those people. So let's change the image. So the Docker file started out as we saw it above, and then this is just a diff. See what we did to just streamline it. So the first change, you can see that we removed the original base image. Tomcat 7 is sort of the default image, for Tomcat 7. It'll have a little extra tools. It's nice to use, and then we can switch it to a slim variant that has fewer things. It's weighs less in terms of disk space and network. So folks will sometimes use it for that reason, but it's also nice for security. We'll add this writable path for later, and then we'll finally remove the package manager actually at the end, because we don't need it when we're in production. So I've pushed these to Kube, which is a registry that has nice streaming. You gotta make it a little wider. These 003 are the ones we're looking at. You can see that this standard image had 103 vulnerabilities, and then the streamlined one had 82. The mix of severities is a little interesting, just because Tomcat 7 and Tomcat 7 Slim are being updated at different cadences, but fewer vulnerabilities, even though maybe the base images were a little out of date. So we lost 20 vulnerabilities and probably more packages than that. So that's the change, and then we can go ahead and deploy that one. There's no real change to the application yet, or to the Kubernetes YAMLs, other than an image tag. We can actually, there's a nice command called kubectl diff that lets you compare with what you've deployed. I've already deployed, so it won't show me anything. We can wait for that to deploy. It's running. And once it's running, we're ready to keep going. We can go ahead and attack this one. And this time we did the exact same request, but then the response actually got echoed back to us. There was wget not found. So we tried to inject code into the application that's running. It actually, did inject. The vulnerability still worked, but then we got to the first step in our process, in our mechanized exploit, and then wget wasn't there. And yeah, that's not necessarily a it's not a silver bullet for protecting you from vulns, but certainly helpful to stymie people that aren't going to spend too much time on you. So we were able to stop the download of code into the container, which is pretty neat. We removed it just by downloading a lighter base image. And then we also have lost things like apt that could also be used to add code as well. There's some notes on the site that I won't necessarily read to you about how to slim down images. Often people will try to use Alpine Linux or another smaller distribution. The Debian Slim or Ubuntu Slim, base images are pretty nice also these days. And if you have something like a static Go binary, you can just use Scratch, which is kind of neat. We'll show a Scratch image later. So that's the first example, just sort of giving you a streamlined image, taking an image and removing some stuff from it to make you a little bit more prepared for folks to try to exploit your application. The next thing that we can do is a read-only root file system. I'll stop after this this next exercise to just get a sense of pacing, but this one's related very much to the previous, so we can just continue here. For this one, the setup is exactly the same as the previous, so we get to skip deploying. And what we're going to do here is show how to mark the root file system of your container as read-only instead of read-write, and how to make certain paths writable if you need them to be writable. it's nice that struts, the struts application actually does need a path like that, so we can show that. So we've already deployed the base application. We can go ahead and just mark it back to the base, the first image, wait for the pod to run. It's already there. The image is probably cached. And then we can attack it just like before. And it'll work. It'll show us crypto miner. About 5 seconds. There we go. So the same thing, same exact thing happened before, which makes sense because we're running on the same attack. Now we were able to download code and run it because we had a writable file system. If we weren't able to do that, we'd wget something to the disk, and it would actually just be like, no, you can't add more code. This is production. What are you thinking? So we can make a pretty simple change to the Docker file, and then also relatively simple change to the Kubernetes YAML to ask for read-only root file system. So I'll do the Kubernetes one first. This is the diff command. That's pretty nice. You can see we changed the image to accommodate this Docker file change. And then in terms of the Kubernetes settings, it's actually just one Boolean. So you just, inside of your container, this is a container level setting. You can set read-only root file system true. And then you've got, it'll make / read-only, unless you opt in other paths. So that's all you have to do in the YAML. In the Docker file, we were using a volume instruction to mark this path writable. There's a note later about how you need to do it in cryo, but this works in Docker. So now we can go ahead and apply a read-only version of our service. You'll see this running in your cluster. Once it's running, you'll be ready to go. And then we can go ahead and attack this one. And we'll do the exact same thing. You notice the command is the exact same. I just realized that, there is a download link for this attack script, I think on the previous page. Yeah, so if you haven't cloned the repository, you can download the attack script yourself, command plus exit, and then run it. Sorry not to have mentioned that before. I've got a local clone, so I just forgot that. So in this one, we don't see an error about wget, but we see this image actually still has that main not slim base image, so it still has wget. Wget runs in our injection. It tries to download something, but then when it tries to write to the file system, it says, oh no, read-only root file system or read-only file system. You're trying to write to something that is not writable at all. So we've been able to block this attempt to add more code to our container and run it. This time just by setting a read-only root file system. This is actually one of my favorite like underused security controls, because if you can't add more stuff to your container, you just block off a lot of sort of lazy assumptions in attacks. And it has the side effect of also enforcing some discipline on application development and operations. So sometimes an application will accidentally start writing to the local file system. Maybe it fills some log there. And this is actually a nice way to root out those problems. If you set everything as read-only early on, then your app will start failing instead of filling up a disk later or something like that. It is easier to do when you're early on in an application before you've maybe started relying on read-write file system for lots of things. If you do need a writable path, there's a note here about how to do that. You can either use a volume instruction in your Docker file if you're only running on Docker, or Kubernetes has a type of volume called an empty dir that works everywhere, including on cryo. Cryo doesn't respect the volume instructions the same way that Docker does. So I want to just take a chance now to run one poll, which is about the workshop pacing. Just want to understand how it's going for everyone, and if you have any things you want to write, you can use the Q&A. But in general, if you'd like the workshop to move faster, slower, same pace, go ahead and answer that in the poll now, and we'll keep that open until we get a reasonable number of responses. Okay, cool. So one faster, three slower, most at the same pace. I will shoot for approximately the same pace, maybe a little slower. If you do have questions where I've glossed over something or something's not clear, please go ahead and use the Q&A so that I can address that with everyone. All right. So now we've taken a Struts application and we've done two things to it. We've streamlined it down to see that blocks use of wget and other convenient tools. We've also marked it read-only. So two kind of app level things you can do to make your application more secure. The next thing is more about host access. So here we're going to cover sort of what host mounts are, how they're risky, and how to use read-only mounts if that works for you. So the example here is actually taken from the Datadog daemon set. Nothing against Datadog, but it is a monitoring tool, so it needs a fair bit of access, and it needs to look at some various things. So if you look at what it's got access to, these are all host mounts in Kubernetes. So it'll access the Docker API, which is gives it a lot of power. The proc directory to understand what all the processes running on the machine are. C groups, which helps you with which namespaces things are in, S6 pod logs for some log aggregation, presumably, and then also a runtime directory for all the containers. This comment is from them, not from me. And then in our example, we'll also mount Etsy just for fun. So what I've done is built a simple container based on those volume mounts. You can inspect the YAML if you wish, but that's what it's going to do. It's made a new namespace and deployed a server in there with all these mounts inside of it. So with all those mounts, we're not even going to try to exploit a vulnerability or something that gets old after a while. We can see, is there a pod running yet? If you see one running, you're ready to go to the next step. And then here's a place where you can have some fun. So I've added some host modifications, info gathering stuff here, that stuff you could do. You'll notice that most of these are prepended with host. That's a common thing when you're mounting host stuff, to just throw it under a directory. It's not required, but makes a lot of sense. So here's where, if you have some interesting ideas about what you could do to a host, if you had access to these directories, that'd be kind of neat. I'll show you a couple. So one of them is let's look at a shadow file, where the password hashes would be if these had any password users. We can look at all the processes on the host, which is kind of neat. See all the command lines. I'm not going to dump all of those, but if you look at what is process ID 1 doing on the host, it's got some funky delimiters here, but it's like systemd doing stuff. It's kind of neat. You can tell you're not in the container when you're looking at this, and you can look at the environment variable, or you could look at them if you wanted to. I've just listed the file. And then you can see also within your container, it also has a proc file system naturally. You can tell here that PID1 is used an Nginx server that I'm running, just because it's a simple image. So if you have any dastardly ideas of what you could do with this kind of access, throw them in the Q&A and we can share them with the group. I had someone, when I gave this workshop in person, I think talk about messing with the file system tab entries, which I think the force is strong with this one. That would be pretty bad. And I should say, this is not necessarily an argument against using a monitoring tool or something that has these mounts, just to pointing at making sure that you've got appropriate compensating controls for making sure people can't just go in and abuse these. So the next thing, if you have ideas, go ahead and throw them in. If not, I'll just continue. So I'll show you one other interesting thing about anything that mounts the Docker socket. This is a policy we built into StackRox for a long time, because mounting the Docker socket is a great way to give people root privileges on your node. So inside the same container, we can just install the Docker client for simplicity. First, put in curl so I can download it. And then we can just use Docker inside of our container to do lots of stuff. assuming your container, assuming your cluster is running Docker. You could use christdtl or something if you weren't. So we did a Docker PS here, and it's expecting a much wider screen, obviously, but this is telling me everything that's running on the host by just talking right to the Docker API server. And we can also run commands on it. In most places, Docker is not super controlled outside of what's in the outside of host access. So you notice the prompt change. This was a pod, and now we're actually in a Ubuntu container that we just ran. So now we can do more stuff. And this was actually running in privileged mode, which I don't think the agent was. So a nice little escalation here. So there's not much else to write here. But now you've got a privileged container running on the node. If you control D, you're back in the pod. And then here I want to show the value of logs. So that's one of those entries. There's a pod log path that's listed. We can go see what we learn about the logs if we wanted to. So say I wanted to see the logs for my container, for my struts container. I can explore these files. Let's see, I'm just going down the directory tree. Oops, and I'm in a container, I don't have less, but I can access all the debug logs out of my struts container. It's kind of an interesting thing to be able to peek at if you're trying to figure out maybe if your application attempts are working. So when you're done, you can just hit Control D to get out. And if you found anything neat, just like throw it in Q&A and we'll share it. So with all that host access, the countermeasures are kind of always going to be app dependent. So we can remove things if we don't need them. We can mark things read only if we don't actually need to modify them. And we can also mount more specific paths depending on if we actually only need like one part of Etsy or something. This is the kind of thing that's a little hard to do from the outside if you don't understand what the app is doing. So better done in collaboration. In my case, I've gone ahead and changed some of the mounts. We use this diff command again to see sort of an improved version, see what the differences are. We can ignore this generation. It's sort of a metadata field. You can see the changes we've done. So the Docker socket, I've marked read only. That won't actually do anything, which we'll see after this. And then changed a few of these log paths to say if we only needed the hostname file, we could get rid of Etsy as like all of Etsy and just give it a hostname instead. And if we didn't need these two log paths or the Docker containers, lib path, we could just omit those. And then this is just repeating what we just said. So those are the improvements that we made, basically marking things read only and removing some of the paths, making them more specific. We can go ahead and apply those. You can make sure these gets deployed. That's already running. It's the same image, so it should be pretty fast. And then we can get inside again. This one, you'll see that some of the exercises we did before, touching the host name, cat, and the password won't necessarily work, but the Docker thing will still work. This is actually an interesting point, which is that marking the Docker socket read only doesn't help. So we can use download Docker now. We can see that we can use it to see what's running. We can still run a privileged container on the host. And that wasn't stopped by us marking it read only. So really the Docker socket is something you've got to be very careful with, no matter what kind of things you're trying to surround it with, because even read only will let you still write containers. And that's the reason why we've got a policy built in for this, and that's something that usually we don't see popping up in customer environments, but if you do, it's always interesting to see what they're doing with Docker API server in a container. So the ways you can do this yourself is primarily using it with, or doing this with the team that knows the application well. You'll be able to maybe understand what kind of host access the thing really needs. Oftentimes we find that people don't really realize what's been added over time. Maybe they're not reading the YAMLs super carefully, or they're not proactively looking at all the YAMLs. So just understanding and maybe enumerating what kind of host access is going on in your cluster, and then talking to the application teams could be helpful. Okay, so we can control D out of this one, and we'll be out of the container, then control D out of the pod. Now we're back on a real computer. No, back on a computer that's sitting in front of me at least. So that's talking about host mounts. Next up, we'll start going toward network segmentation. I know a fair number of folks expressed that they were interested in network segmentation as one of their sort of security priorities earlier on in the poll. So in this one, this is going to be primarily about pod level networking. So we'll talk about sort of how pods have access to each other and how you can go ahead and limit that access. For this one, it's modeled after the Shopify Bugbounty report, which I should link here, but it's on HackerOne. And effectively what happened is there was like a preview tool, like a screenshot taker thing, and it didn't have network policies on it. So you could coerce it into accessing the Google Cloud metadata server, and then you could see a little screenshot of what the API server returned, and then you could use that to steal a Google service account and get into the cloud account itself, which is, that was a fun report to read, and it should still be public. So worth reading. It takes maybe 5-10 minutes to read. So we'll have an application that's kind of similar like that. The code's here if you're interested, but basically it'll take a URL parameter and it will just go and get it and then catch it to the screen. So like a very, very simple server-side request forgery that's easy enough to use in this kind of demo environment. All this code and stuff is in the workshop repository on GitHub also. So if you want to check it out later. So that's the application code. Is just this really simple, /fetch with a URL parameter. The Docker file is actually very, very small. So this is, I mentioned Scratch earlier. This is a static Go binary, so I can just copy it right in, and that's all I need. And this image will be like 10 megabytes or something, maybe 5, I don't know. And it will have nothing else in the file system, just this one binary, which is fairly neat. There are other kinds of minimal options that you can use if you're thinking about doing sort of like the streamlining thing from the first exercise. So let's go ahead and like get this thing deployed and start abusing it. So once that's running, this one we'll use in the browser actually, because we don't need to try to do it in the command line terminal, easier to see it in the browser. So I have a little link there. It's just a convenience to open up the URL. But if you don't have your nvar set or something, just go ahead and access your node on port 31302. And that will, this one opens up a check IP service. So if you see this, or well, now you know my IP, well, you know the node's IP. So that's what you're looking for. And then in terms of the, I guess, quote unquote attack, we'll use our little fake exploit to access different things. I've included some examples, but if there are other things that you come up with, that's another thing you can throw in the Q&A and we can chat about together. So this is the example of showing the node's IP. The cloud provider metadata server is how Shopify was compromised, or was compromised during the bug bounty. You can see there, that's the 169.254, 169.254. That's the metadata server in basically all environments. If you then go through different paths, you can see what you can see. This one is starting to show some concealment behavior in V1 of their API. In V1 beta 1, we should be able to keep going in and see things about what this instance is. We can find its ID. We can get its host name. You can see where I am in my environment. There's going to be a Kube in one of these things, but we can keep sort of poking around. All kinds of interesting stuff. And Google has been, the bug bounty came around, I don't know, 2 years ago. And Google has been taking a lot of, making a lot of changes over time to sort of block off this method of attack, even if you're not, taking steps yourself. So that's interesting. So that's just an example of all the stuff in a metadata server. Other providers may not have the same kind of controls, so that'd be interesting to check in your environment. Obviously, it won't work in something like Docker for Mac or something. It doesn't have a metadata server. We can also try using this pods network, because that's what we're doing. We're injecting a URL into the pods network context, and then using the pod to reach out. We can reach out to Kubernetes. Kubernetes has a nice handy host name, Kubernetes.default. In this case, it's doing the right thing. It's telling us, hey, like, you're not allowed to see stuff because you don't have any creds. That is the limitation of these kinds of attacks, is you're using whatever access the pod has intrinsically, and you're not able to necessarily include like headers and stuff. A nice one in GKE, at least, in some environments it's disabled, is the Kubelet read-only API. A nice example of like a new attack surface that obviously didn't exist before Kubernetes is the Kubelet, because who uses the Kubelet outside Kubernetes? So this is a read-only API port, and it just gives, it's read-only, so you can't change things, but you can leak a lot of information. And so this one is, for instance, is a pod list, and it's going to tell us about every single pod running on the machine, which is actually kind of interesting. So if you type, I guess we don't have any Nginx on here, but our struts pod actually shows up here. You can see that it's in the namespace struts with different pods, and it's got a pod name. You can see lots of information about secrets, which things are mounted, at least different paths that we'll see. So big information leak if you're breaking into a cluster. And just to show that it works on other pods as well, we can try struts. So here, this is what the little struts showcase app looks like. I think it's just not getting some styles and stuff, but you can see that you can access the meat of the page. So the answer for this is going to be network policy. I'll go ahead and show the difference. This is going to add a network policy. Yep. Because we didn't have one before. So now we'll add a pod network policy, and that means that the pod will start to opt into network policies. If you don't have a policy, everything's unconstrained. One of those not so great defaults, or it's great for getting started, but not great for security. So we can add a network policy. This is all the boilerplate, and then here we're saying which pods it applies to. So it's going to look in the SSRF namespace. It's going to look for things that are labeled app preview, which our app is, and then it'll talk about egress. And with no other options, it will use that to block egress. We can go ahead and apply that policy and see that the namespace wasn't changed, the app itself was not changed, the service wasn't changed. We just made a new network policy. And now we can just go ahead and try the same things. So if we refresh the page, it's hanging now, and it's going to time out eventually. It's saying, hey, like, I actually couldn't talk to struts anymore from my application now that you've added this policy. You can talk to some things potentially. The rules can take a little bit of time to apply. The kubelet one's not working, and the Kube default also is probably dying here. Yeah, and the metadata server should also, this will all be timing out, which is great. That's what we want. If your application doesn't need to reach out to things, then might as well not. The other neat thing is that Kubernetes policies do apply to connections, not packets. So with an egress policy on like this, it's not saying like no packets can leave. It's just saying you can't make a connection out. So you can still expose this app. You can see that we're talking to it, but it just won't be able to proactively reach out, which is pretty nice. If you're on a cluster like Docker for Mac, network policies aren't going to work for you unless you've changed it. I don't know the status of the defaults in all the environments, but if that still works for you, it's likely that your network policies aren't enforced. That was the countermeasure there. And obviously you're not gonna be able to do egress if you have an egress policy. Those can be a little bit complicated to get deployed. So I've linked to like an ingress and egress guide that one of my coworkers wrote about how you might be able to get started with those and some more background. Cool. So that's networking. Again, if anything comes up in your mind, or if something's not working, or you've got a question, go ahead and use the Q&A box, and I'll talk about it with everybody. So the next one we can do is sort of move to a Kubernetes native, or Kubernetes attack surface itself. Talk about Kubernetes RBAC and service account provisioning. So in this one, the Kubernetes API is a super powerful piece of attack surface. It's where you're going to go ask all the questions. I want these YAMLs to be deployed in my cluster. So it's super powerful. It's going to do everything for you. So access to it is going to be very, very important to protect. And by default, pods do get a service account that lets them access the API server. They don't get much access in it, but most environments, but they'll have some access. So let's go ahead and deploy an application. In this case, I've got two YAMLs here. One of them is for the application, the other one's for the RBAC. Just because the RBAC stuff can be a little bit more complicated to deploy. We've got a new namespace. Let's see if this thing's deployed yet. Great. And again, we're going to use we're just going to go into a shell. We don't need to try to layer on the exploits here. So we can just go ahead and exec inside of this pod. So if we want to go see, this is basically a default YAML, so it doesn't have any kind of changes to it. This is just right out of the box, more or less. We can just go ahead and see what we're allowed to do inside this container. So go ahead and install curl, and then add kubectl. Sorry if that's grating to you. I just grew up saying kubectl. And now we can see whether we've got a service account, and then try to use the command line to see what you're allowed to do. So if you see this path, this is where Kubernetes will throw a service account by default unless you tell it not to. And it'll have a CA cert for I believe for the API server, tell you what namespace you are and the token that you've got. So like mine, I can show you. It looks like a jot. It should tell me an SA. So it doesn't have a parameter, a separator, but it tells you what namespace you're in, what CA cert and what kind of token you're going to have to access the API server. And kubectl will just pick that up by default. It works pretty nicely, and it'll tell you there's a nice command, auth can I, and you can ask it hey, can I do the following? There's also a list option that will tell you a list of things you're allowed to do. So it's super useful if you're trying to understand what access you have in an environment. So the stars at the top are immediately something to care about. Resources and resource names with any verbs is a little bit star, meaning we can do anything to anything, at least within a namespace, which is a little bit funky. Ian Coldwater will say we're all made of stars. Your RBAC shouldn't be like that one. Let's see kind of what we're allowed to do. So in this, your cluster might act a little different depending on how it's set up. I believe the first one works in Docker for Mac based on their default configs. It doesn't work in GKE. That's trying to get pods across all namespaces. This one we can just look in our own namespace, and in this case it'll work. I'll be able to see myself using the Kubernetes API, and then I can actually run another container, sort of like how we use Docker to run a container. We can use kubectl run, which is a fairly convenient thing. So you can run an Ubuntu image with a shell, and say, hey, we don't have much here. It's got a got a container to run, and we're running in our cluster now, which is kind of neat. And that's sort of by default in a GKE cluster, what access you have. Kind of alarming, actually. So that's just what we had for default. And then the things we can do to fix that, we can either we can change the role that's granted to the account. We can also disable the auto mount, so it doesn't even get a token in the first place. So auth, like I mentioned, has a little bit of a funky YAML structure with if you want to remove things or whatever. So there's a special command called auth reconcile that will help us apply RBAC better. So when I streamline the RBAC, I want to be able to delete some stuff and change some other stuff. This auth reconcile will help me. You can see it tells you what it's doing. So it added a new rule and reconciled some other ones, it looks like, which is good. And we can apply a new, I'll do a diff first, actually. We can see what the difference is on a node service account mount. In fact, I'll go ahead and show you how the access changed with that. So now the star is gone with just the new RBAC rules, which is kind of nice. We don't have that access happening anymore. Actually, and that reminds me, I may have misspoken. That might not be by default, but it's just an RBAC rule that I applied. And then we can change to not even mount a service account. That'll require a redeployment. So I can go ahead and see that it's deployed, go inside, do the same thing that we did before. And we'll note there's no, inside of our run, there's gonna be no service account mount directory at all. So we could go ahead and download kubectl again. I don't think I will. But you would show that you can't actually access the API server anymore because you don't have a token here and there's no way for you to get one. So you can do this by disabling the pod, the automount service account token field. I'll just go ahead and try to show that real fast, where that is. Just using a kubectl diff. So there's just one thing in your pod spec where you can say like, I'd actually not like a service account token, don't bother. And then there's also one in the service account spec. You should read the docs just to be sure you understand how those interact because they both have defaults and they don't necessarily act the way you would think. So that's Kubernetes RBAC showing how a initial configuration might leave you a little bit more exposed than you'd like, and then how you can take your RBAC and streamline it a little bit and disable service account token mounts if you don't need it. Most applications don't really need Kubernetes API access at all, so it's a nice sort of easy app by app lockdown you can apply. So RBAC is oriented around namespaces. You might have seen up here that sort of there are stars and different. We were able to say not see things across namespaces, but we could see pods in our namespace. So namespaces are a really important security kind of speed bump. At least they're not a container, or they're not a an isolation boundary per se. It's not a hypervisor or something. You might still schedule next to each other, but namespaces can be at least a good security speed bump. So we'll see, how that works in a couple contexts, both in terms of network policies and just things you are and aren't allowed to do if you're across a namespace. So we can start with just like this YAML. It'll deploy, a new service, one called server, one called bad server. They're actually the same, but we'll see kind of how two applications living next to each other in the same namespace might share a little more than they should. Go ahead. So in this case, like we can see that there's a bad server pod running. We can also check that there's a server one running, and they're running in the same namespace. They're running in the default namespace, I believe. Yes. So if we go ahead and go into the bad server, our goal, I should say, is that your bad server shouldn't be able to do the same things as your good server. It should be able to talk to the good server. Maybe it's some untrustworthy deployment or something. We can do the same kind of deal where we install curl and then try to use it. We're in the bad server, and our security goal here is not to be able to talk just to the real server. But if we go ahead and curl it, we get the standard Nginx response. So we're able to talk to server, which we didn't necessarily want. And then I also made a mistake in my YAML. Maybe I copied it from server and I didn't remove something. So now I can see like maybe the sensitive config where I've got like my proxy, my auth proxy that has a username and password. This is kind of a contrived example, obviously, but this bad server is not supposed to have this stuff, and I kind of want to know how this happened and maybe fix it in the future. So what we're going to do then is try to move things into a different namespace. So I can show you sort of where we started. We had a network policy that allowed access within the same namespace. We had a secret that had that proxy stuff in it, and then it had 2 deployments. It would be easy to miss that we had this volume mount here. And that we had accidentally copied it over to bad server. That's kind of what we're looking at. And since they're both in the namespace default, which you can see up in the metadata, that's why we're in this bad situation. So we can go ahead and split those out, delete the old stuff, and then try to split it up first. In this case, I made a different mistake. I copied over that server YAML, but I forgot to change the proxy config. And this is actually an example where the namespace will help us, because let's see how this pod is going. Stuck in container creating, see if it gives us an error. You have to describe it to be able to see that, because it's just going to keep trying to create. It says like, hey, I tried to set up this volume mount that you asked for, and I couldn't find secret config. And that's because if we read the YAML, what's it called? Secret config. The good server can mount it, and then I just copy that into bad server. You can see we're in the bad server YAML now. But this secret mount doesn't actually take a namespace parameter. It only takes a name. And if we're in a different namespace, if we put bad server in bad and good server in the good namespace, there is nothing by that name. Like we can't say we want like good namespace secrets config. You're limited to mounting the things in the API. You're limited to mounting things in the same namespace. Oops. So it's telling us like, hey, like we actually can't mount the secret that you forgot to take out of your YAML, which is kind of nice. And it shows you that like if you've got secrets or sensitive stuff, if you want to keep that in a separate namespace, it's a little easier to keep people from accidentally grabbing them or maliciously grabbing them. So we can fix that just by like removing the mount. And now we can check that the pod deploys. It's running. And now if we try to do the same stuff we did before, go ahead and install curl. We're in the bad server again. So now we're trying to talk to the good server. Notice we actually had to add this .good on the end because it's in a different namespace. You can't just say server anymore once you're across namespaces, which is also nice. You can give it a little bit of separation. And since network policies are enforced in my cluster, we added the existing network policy that said, hey, I only accept connections from within my namespace. That's working here. Because we're across namespace boundaries, we'd have to add a special network policy rule to allow this bad server to talk to good server. Just make sure everything kind of still works. Like we can still talk to ourselves. So we can still talk to bad server. We just can't talk to the good server anymore, which was sort of our security goal here. And also the proxy config won't be mounted. So we can just go ahead and get out of that pod now. And just an example of how your network segmentation will be improved if you start separating stuff into namespaces, and how we can't even accidentally take a secret that's not really meant to be ours across namespace boundaries. So people often ask sort of like, how would you do namespaces? Different folks have different answers. Sometimes it'll be by team, sometimes by like service tier, like which is this a backend or front end or database tier or something like that. It kind of depends on your organization and who's responsible for things. I'd typically like to see the people or the application architecture reflected in namespaces. Another strategy is to just take very sensitive stuff and put it in its own namespace for this kind of reason. So those are namespaces. Nice little security speed bump to prevent sort of a lot of security stuff is not necessarily malice, but mistakes or mistakes that get abused. So a nice way to maybe minimize some mistakes. So we've got a couple more. At this point, I can do the poll one more time just to see if there's any kind of guidance on how people feel about the pace. Maybe we can throw that up, that poll up now before we move on to the non-root user. Okay, and I see that we have one question here. So what would be the recommendation for namespaces or external tooling like cluster autoscaler, monitoring, logging, etc.? I'm not sure I have a great answer. The stuff that's going to be in Kube system and things like that, obviously you're not going to be able to mess with. Kube system also has things that apply differently, like network policies. They just don't work if you apply them. If you do have sort of infrastructure stuff, that can be nice to, if you have infrastructure stuff, it can be nice to keep that separate from your applications at least. Not certain exactly what to tell you there, I'm sorry. Looks like we have, in terms of the poll about pacing, a little bit of requests for slower, a fair number for the same pace. I'll shoot for same with a little bit of slow. If you do have a question where something wasn't clear, like please do show it in the Q&A so that we can help. Okay. All right. Let's go back to the exercises then. So we've got a couple more. This one is about using a non-root user. So I mentioned earlier that one of the kind of unfortunate defaults in Kubernetes is that everything runs as root. And then because most people don't remap users, container root is the same as host root. That's kind of unfortunate. So we'll just use a simple shell to get into this app. I think there's a simple app here that's going to run a server. The server doesn't do much, just sort of listens on a port and logs through the path. And we'll show how you can fix that to work in a non-root identity. You can see also it's a simple Docker image, so it's just going to go from Alpine and then just copy the static binary in. We can go ahead and deploy that application. It's got a little service. And we can go ahead and exec into it. Looks like it's running. Nice thing about Alpine stuff is it's going to be really small. So here we'll be running as root, I believe. Right. So who am I? Root. That means I can do lots of fun stuff. There's a little there's a host mount, I believe, so you can shove things out to the host. Maybe don't do this if you're going to keep this cluster. I'm going to throw it away at the end. If there are other things you want to think about, this is similar to the host mount problem. So basically, you're showing that you can modify the host with this root identity. So less of an attack, more of a just showing that root is root. And really, the meat of this one is discussing how we can get to non-root. So this will go in a couple steps. So Kubernetes does have this security context option called run as non-root. And this is comparing a new version of the YAML to the one we have deployed. So this one is going to just add a security context option that says run as non-root true. Now we haven't actually changed the image to use a non-root user. So this is we can see what happens if we just set the setting. I think I might have applied this the first time and like, oh great, cool. It'll just like pick a non-root user and run my app under it. That's not what it does. So if you go see what the pods are doing now, here's our old one, the one we deployed 2 minutes ago, and then this is the one we just tried to deploy, and it's telling us, hey, like something's wrong here. So if you go ahead and kubectl describe server. It's got actually a pretty good error message at the bottom. It's saying the kubelet is complaining. So it got all the way to the kubelet, got scheduled, and then it says, hey, this container has run as non-root set, but the image is going to run as root. This is a place where your configurations are applying across the stack, where we've got something in the image and something in Kubernetes kind of combining, and they're getting enforced at the kubelet when the kubelet starts to run the container. So we didn't actually forget, we actually kind of forgot to change the image. So now we can fix that before we go. So the Docker file, all I have to do is add a user instruction. Usually you'll do this like last in the Docker file so that you can do all your app installation and whatever first, and then you sort of switch down to a different user. You can pick different numbers. It's best to have a little bit of strategy around this, and people often use these high numbers because they're never going to be in the actual infrastructure. So 1,000 will just be some random ID usually. And then we see there's one more change in the YAML just to pull in that new image, and actually the image, okay. So we've changed the image to have that user instruction, and then the app actually also needed to be modified a little bit because it was listening on port 80, and if you're not root by default, you can't do that. You've got to use a higher numbered port. So we can just change the command entry to use non-default, stop using the file system, and use a port that's not in that privileged range of 1024 or below. And the nice thing about Kubernetes having pods and services separate is that you can change this container port. You can change from 80 to 8080, and you can then change your service object to point to 8080, so you don't have to change your external exposure. It'll still remap 31303 to 8080 in this case. So now we can roll out that change. Our pods should actually come up now. Yeah. So our old pod went away and our new pod came up, and this one's not going to be running as root anymore. So we can go inside of it. Who am I this time? Some unknown UID, and then say we tried to do the same thing that like root could do before, and it's just like, no, we're not allowed to do this. That's actually pretty neat. It shows you how a safeguard in your YAML, the run as non-root true, can enforce things about your image policy just as a aspect of your image configuration. You can also try to enforce this in your images as well, but the Kubernetes config here will help you keep that on. And you can also try to require that setting be on in all your deployments, which means that all your images will have to run as non-root. But there will be some of those application changes sometimes. So like either changing port numbers or changing the behaviors to not use the path or something like that. It's better to use standard out anyway for logs, for instance, so this wasn't too disruptive. Okay, I see we have a couple questions here. What would be the difference between using a user in the Docker file versus using run as user from the security context? That is a good question. I don't know off the top of my head. I'm sorry that I didn't prepare that specific part. My recollection is, the FS groups and stuff will be like an additional group identity run as user. I am not fresh on, sorry. And then what about running sidecar containers that are running as root? My use cases are Nginx, stable, Alpine. So with all these exercises, there's sometimes going to be good use cases for root or for privileged or for host mounts. Like Datadog was an example of something that had lots of mounts, but it's actually useful mounts because it does a thing for you. It monitors your containers. It does performance monitoring, log aggregation, all that kind of stuff. So what the framing of all this stuff is sort of not that you might not that you should never use them, but that you should be using them carefully. And in most cases, applications don't need this level of access. So, but if they do, it's actually a risk you can take. But it's just a risk you probably don't need to be taking with all your applications. Like this little simple dumb server doesn't need to run as root. All it's doing is serving, a simple little request. It doesn't need to be running as root, so it can be import 80. So that's it's more about what risks you need to take than what should you never do. Hope that makes sense. And thank you for that clarification. Appreciate it. So yeah, running as non-root can be a good way to minimize your security exposure a little bit. I mentioned earlier that the run C CVE kind of got people more attuned to this. That CVE was an example where the run C itself could be abused to overwrite things on the host if you were running as root or as an appropriately privileged user. So if you were running not as root, you were in a much better position in your application. Okay, so it looks like one more question too. Great. Would it be possible to configure all the pods or containers not to run as root with some cluster level configuration instead of making changes in each pod or deployment YAML? So to my knowledge, no, you can enforce that, you can require that things work this way, but you can't necessarily do it unless you tried to do some like mutating webhook or something. I'd be careful with that kind of mutating strategy where you're changing deployments because it will make it harder to test and relies on the cluster changing things. Probably better to have things specified in YAMLs, in whatever place you're storing YAMLs or configurations. Okay. And if I haven't answered any of these questions, do feel free to do a follow-up. Okay, so could using the sidecar with run as user be a solution since we don't have control over the image itself without adding the overhead of maintaining a copy of the image? Sure. So yeah, in most cases, or in this case, I was assuming that we built that application image and the container image was kind of our creation. So we could go ahead and put in the image as a nice default. But if you're, for instance, bringing in vendor solutions or something, or taking an official image, run as user could be a nice way to fix that. That's a good question. In that case, you'd still have the same kind of consistency problem between run as non-root. You'd have to make sure that if you set that, you'd also have to go set your run as user. I would presume. I've typically just ended up doing the image thing because I tend to be working with applications that I've originated versus ones that are from vendors or outside libraries and stuff. Okay. So, and then there are some examples also of like Nginx where it will start as root and then create worker processes with a lower identity. So those I tend not to necessarily worry about with the root thing. Although it'd be nice if we didn't have to do that. Great, thank you for the questions, folks. And again, please, even if I'm about to move on to the privilege mode one, but if you have more questions, feel free to add. Okay, so let's talk about avoiding privilege mode. This one's a fun example from Yin Coldwater and Duffy Cooley that they've given in a few places. So he's got this lovely like one tweet to root. So we can go ahead and like deploy Nginx. I'm going to do it as a deployment and scale it just to get one running on every machine. It's not necessarily required for this, but it's an easier way to adjust or to demonstrate. So I copied out the command here, so you can click and paste. We'll just run this in our cluster and see all the things you can do with a privileged container. Press enter. Okay, cool. We got our command, and it's pretty printed down here also, so you can see kind of to fit in 280 you can't use line breaks, but you can see all the options here. So it's enabled host PID namespace true, so it'll start processes in the same namespace as the host. That it's privileged as well in the security context. We'll attach a terminal. That's easy. And then the command is that it's going to enter the host's process 1, so the host's initialization process, and just running a simple outline image, which is pretty fun here. So once we're in here, we can do all kinds of things because we've used Kubernetes to just like get onto the host as root with all the privileges. Let's see. So just as a couple examples, this is a place where if you've got some interesting ideas, you can go ahead. But you can see that we can see all the processes that are running, including in other containers. We can go find Nginx. So we just entered, this deployment ran on one host, and then we can go find all the Nginx things running somewhere else or running on that same node. We can even enter the namespace of those processes and see what is going on. You can see the connections that are open. We're listening. We can go see the Nginx config in that other container, which is also kind of fun. See, this is pretty bog standard Nginx. And then we can even go back to the host namespace and see what's the namespace, see what it's like, some things on the host. So lots of fun if you've got host PID and privileged. If there are any other things you want to share, please throw them in the Q&A. We can talk about them. So I'm not going to keep poking around here. I want to make sure we stay on time, but feel free to in yours. And the countermeasure here is like, don't do that. So if you're not really needing privileged or host PID, don't use them because they provide this level of access. Most applications shouldn't need this kind of elevated host access. This is the kind of thing that some built-in policies in StackRox, for instance, will look for this kind of stuff. And then the way that, so if you want to actually enforce that this is happening, you want to use a mission control, whether like a dynamic mission controller like StackRox or a pod security policy or something like that to block those containers by default, unless you know what's going on. So if we just change a couple things, this is going to take host PID and make it false. We can see it will not work. So we can't, we could probably fix it to work, but it's not going to be able to use bash because it's not able to get into PID1 on the host. It's not really helpful. And then the privileged false also will prevent it from being able to use, these mounts. So those two are sort of a deadly combination. In terms of what you can do instead of using privileged, there's some capability settings in security context where you can say, I don't need privilege, but I would like certain Linux capabilities. Like I'd like to be able to use raw sockets or something like that. There's some interesting tools one's called Capable from Brendan Craig that can tell you sort of which capabilities you're using. But going back to sort of the declarative immutable world of Kubernetes, all these changes can go through CI and testing, like any code change, because they're right in the YAML, which is kind of nice. There's a whole talk about privileged containers from B-Sides SF this year, before we all begin sheltering in place, that you might want to watch about privileged containers too. Cool. So that's privileges and sort of host process privileges. The final one is actually going to be resource limits before we wrap up. So we've been able to stay mostly on time. And for this one, we're going to show sort of like what resource limits are and what happens if you don't apply them. And this is actually an interesting place where people might think of this more as like an operations thing or a reliability thing. But in security, we often concentrate more on confidentiality, integrity, and we forget about the A and the CIA triad. We forget about availability being actually a key responsibility as well. So this is a place where people across our different communities can derive some shared value out of a single configuration. Sort of like labeling helps everyone understand what things are. Applying resource limits can help you keep your app available, whether you're primarily in an ops role or primarily in security, or whether you're in one of those unicorn DevSecOps teams that I'm told exist. So in this one, it's inspired by sort of a memory exhaustion attack that has gone around in various languages, and in particular in Kubernetes. There was called billion laughs in YAML. The laughs comes from XML when it was called LOL or something. but YAML and XML are sort of too complicated for their own good sometimes. You can build these exploding manifests that reference each other in many ways and just take up too much memory. So this is actually the subject of Kubernetes CVE. And this is a reason why you might want to be limiting your API server access, especially against the entire internet, because you'll have a lot of, if you're running an unpatched version and someone can just come up and blow up your API server by sending a manifest, that's not very good. So it's inspired by this. It's not quite the same. This little basic application, I've called it Memory Exploder, just takes a parameter and will allocate a slice that is as big as the parameter you send it. So obviously that's not something you should ever do. But if your application takes user input, it may be processing something complicated like YAML or JSON, or maybe doing something complicated on the user's behalf. It makes sense to try to limit that. This is a little handler that just takes a parameter and makes that slice. So we can go ahead and deploy it. This one will not have any limits or anything when we deploy it. By default, you'll have some kind of resource requests applied in most environments, usually pretty minimal, like 10 millicores or something, like 0.01 cores, but you won't have a limit. So we'll see how that works. If I just call my application with a little, address, it's going to say, yep, cool. I got, what, 4096 bytes or whatever. It's not much. Go ahead and try to do the kubectl top here before I break it. Looks like metrics may not be available. We can get pods and watch that happening. So now I can try to allocate a ton of memory and see kind of what happens. It's just going to hang here because it's going to allocate a bunch of memory. And we should see the pod, depending on your cluster, it'll either kind of get evicted or potentially killed or something. Won't get killed without a limit, but you may see it get evicted. Sometimes it takes a little while. It's kind of like watching water boil, but this request obviously won't do the thing. And it looks like we did in fact get a couple pods evicted here, and that's trying to replace them. So I'm gonna kill that Control C and then try to give this pod a chance to come back. You can see that if we describe one of these pods, we'll see that it actually got evicted probably for memory pressure reasons. So yeah, it got evicted because the node had some memory pressure. So this is an example of one application that's able to, tell Kubernetes like, hey, I'm in trouble, and cause other applications to get moved around. One of the other pods was probably the one that got evicted because it was using too much memory. You'll see a different error if you see that. Different places will have either Docker stats or kubectl top. You can see that it was using a ton of memory. So the way to stop that is to apply some limits. And in this case, like we started off with empty resource requests or limits, and then added some requests. And then some limits. So people will have different opinions on how these should go. The one thing to remember is if your requests and limits are the same, you'll get guaranteed quality of service because you're agreeing to be limited and you're requesting exactly what you need. Otherwise, you get sort of a best effort scheduling. So here we can say, like, I'd like to request like some medium amount, and then say I'll limit myself to something 10 times higher. Some people like smaller multiples on that, but it's normal to have your limits oversubscribed. And what happens with a CPU limit is it will sort of nice your process down. It'll just slow it down. With memory, you'll get killed if you use too much memory. It's a little bit brute force. So that can be that's one reason to be careful with your limits here. So we can go ahead and deploy that, and it'll be on the same node port. So we can go ahead and see if our pod comes up. We've got one running, great. And then we can go get it. And weird, so it failed fast, and it failed with this empty reply from server, which is different. now we can go check that pod and see it's still running, but it actually got restarted once. And if we want to go describe it, we can see what happened. It will tell us in an event. It should tell us actually up in the status. We should have a thing about last state. Yeah, so the last state was terminated. It got killed, so it got out of memory and was killed, and then exited with 137. So 128 plus 9 for kill. So shows us how we got killed for this. Okay, so there's a good question right now is how to estimate CPU and memory limits for the app. Developers will ask how to do that. It's a good question. I don't have an easy answer. I think it depends a little bit on your type of application. So if you're in Go, one thing that we do is use like the built-in profiler and stuff. That's can be really helpful because it can show you your heap profile, how much you're using, that kind of thing. It's going to be some app knowledge here too. So if you know that an application is going to be processing a lot of data, doing a lot of in-memory stuff, allocating and deallocating, you might want to bump it up a little higher. Often you're not really walking a fine line on like how many megabytes you're allowed to have, but you can kind of do something reasonable and then monitor it in a real workload and make sure that it's not getting killed, and make sure that your performance isn't suffering because of your CPU limit. In particular, because kills are disruptive, I typically would say set your memory limit higher than you think, as kind of a stopping a runaway train thing, not as a more fine-tuned limit, because it will just get killed, and that actually can lead to more memory pressure if you're having to redo work or something. So any recommendations on request or limit ratios? My experience is that sometimes they're too high and they have noisy neighbors, or if it's too high, you have noisy neighbors. If it's too low, you're overcommitting the ratio. So that's a good question. You see actually in this app we did like a 10x. That's probably a little higher than I would generally do. Some folks that we talk to is that we'll go for more like 2x or something. So that some people will say it should be much more like 1x. I don't tend to agree with that personally, because it doesn't let you have any kind of bursting. So I don't know, somewhere 2 or higher, probably less than 10. My colleague Karen's also mentioning to me that you can use the Kubernetes vertical pod autoscaler to try to find and automatically tune for app resources. So that's a nice Kubernetes resource that you can use. I don't have any other tools that I could recommend. Any tools for finding out the CPU and memory utilization. So kubectl top will do a decent job for running pods. If you're in a application, that's where I was going with Go. Like if you have Go, you can try to use their built-in profiling stuff. With Java, I know I don't do too much Java these days, but the heap profiling and stuff will be potentially useful. In terms of CPU, I tend to say like just run it with a real workload and see if you're getting nice down, or if you're getting if you're oversubscribed. So that's my opinion. But I have less of an ops background, more of a security and engineering background, so I don't listen just to me. And then Karen's also reminding me that the JVM stuff, remembering that your heap size that you allocate to the JVM is not actually going to be with your full footprint. So the Java process will get in memory, some other stuff will get, libraries will get loaded into memory, and there'll be some overhead on top of your heap. So if you're tuning, just be careful, understand the application that you're trying to tune, and make sure that you're applying the right limit for the Linux process, for the Linux container, and not making that match what the JVM thinks or something. Thanks, James. Cool. So the how to use it yourself, obviously, is to go ahead and add requests and limits. And we've talked a little about how you might be able to get those numbers. In practice, these things I think take a little bit of time to settle on. So some of those, you'll figure out. This is actually the too low CPU limit with RSA. That's a very personal problem that I had, where we tried taking a very quiet application to a very low CPU limit, and then trying to do TLS doesn't work. So with like a 0.1 CPU, so that's been a problem in the past for me. And then if you see your stuff getting killed a lot, then obviously you'd want to maybe either figure out your you'd want to maybe either fix your app or fix the limit. So that's actually it for the exercises. I hope that was sort of a whirlwind tour of a bunch of different Kubernetes resources. I'll do a little bit of wrap up first, and then we'll be able to answer any final questions. Sorry for bumping you through all those slides. So the one thing I want to talk about is with all those configurations, you want to get these, you want to get better at some of these. You want to start using one of these or two of these in your environment. Without actually losing the velocity that brought you to Kubernetes or containers. So let's figure out how to do that. So without losing velocity or friends, these things can be very contentious sometimes. So on enforcement workflows, one of the neat things in Kubernetes is trying to use emission control. This is an example from one of my colleagues' blogs about emission control in general. So he has a good blog on the Kubernetes.io blog about how you can do emission control. It can be a little complicated, and we've figured out a lot of this stuff within StackRox. So it's a feature of the StackRox Kubernetes security platform as well. But you can see that the feedback is right here. So when you created this resource, you immediately get the error before it even tries to deploy, saying like, hey, you actually asked for run as non-root, but you forgot to do run as user. It's the right time to give the feedback, is like before you deploy, before it starts breaking, or before you try to like kill something for not violating your policy or for not following your policy. A much more friendly place to see. And then, so I have sort of a staged rollout kind of plan. One way you could get started with all these things. So I like to say, like, start with the easy stuff that helps everybody. So annotate, label your deployments consistently, so people know what they're looking at. Start using concrete image tags. Like latest is convenient, but can lead to you not knowing what actually is deployed. You'd have to look at SHAs, which is less convenient than tags. And then you can start scanning images using either a registry like Quay, a security platform like StackRox, to try to figure out sort of your heaviest weight images and figure out where the CVEs are, and the fixable ones especially. That helps everybody. We can continue with other self-contained changes, sort of app by app, or self-contained that affect different communities at once. So limiting network access to the API server is great, especially if you're worried about Kubernetes API server CVEs. There've been a bunch of them in the last year or so. You can start disabling that automatic service account mount, either namespace by namespace or app by app. And then you can try to look at, if you've got people that have cluster admin, you can think about replacing them with a little more scoped access. So when our product will show you people that are cluster admins and maybe help you figure out what to do with them. And then moving on, like, to especially the stuff we showed today, you can work on those kind of cross-functional changes that might affect different people app by app, which is nice. You don't have to do a whole cluster migration. You can try a read-only root file system for certain services, especially the stateless ones. Maybe you've got some web front end or whatever, and that can help. You can make sure resource requirements are specified. That goes obviously pod or deployment by deployment. And then you can start, because network policies are opt-in, you can go app by app and say, like, hey, for my most sensitive things, I'll add an ingress network policy, and work up to having them for everything. And you can do the same thing for egress. If certain apps will never need to do egress, you can just go ahead and apply a change there. It's nice because you don't have to say, all right, everybody, starting Friday at 9 p.m., no egress allowed unless you're on this list. You can just go application by application, test the changes the same way you'd test different kinds of YAML configurations. That's nice. And then just keep going. So there's always more features coming out. Kubernetes has been adding different kinds of things you can do to help lock down your cluster. And just, this is a loop. This is not a you get to one place and you're secure forever. Doing consistent monitoring, visibility, inspection is going to help you in the long term. That's a place where actually I'm a product manager, and that's one of the reasons why we built a product like we do, which enables visibility and sort of debugging and inspection and runtime monitoring, so that you can keep going through that loop of fixing things and build and deploy, watching them in runtime, finding out new things to fix, so that you can continually improve your security posture with all the context that we have from Kubernetes. Great. So there are a couple links here. We'll share this with you after. I wrote a blog about the security audit, which is available at that link. There are some good KubeCon videos about security, especially a workshop somewhat like this one, which I took some inspiration from, and then the StackRox blog. You can also email me or reach out to me on Twitter. I'm happy to answer questions. And I promise to answer you faster than sometimes I have in the past. Just one final plug, there's a meetup group that we're setting up, where some events are going to get scheduled with Karen and some other folks from StackRox, and there's a link there for you there. And now I'm happy to take any additional questions before we hit the 11:30 time. I see we have one in here so far. So what are the concerns in switching your CNI on a running cluster? The reason is that introducing network policies are not supported by the AWS VPC CNI. And Karen's saying that you can install Calico at any time in EKS, and it will still default to open network policies until you start adding your own. This does bring up a good point that your CNI provider will impact what your whether your network policies have any effect. In Google, for instance, there will be an option that you need to do for dash enable network policies. In different platforms, it'll be a little different. Karen has written some great explanations of the details of every one of those platforms, or especially EKS, which I believe was your focus, Mikhail. We also have one final poll, just to get your sense of how this works. So we can do this better next time. And if you have any other questions, feel free to keep adding them in the Q&A. And if you're going to drop off, I want to say thank you for spending the time with us. It was a lot of fun to go through this again with folks, and I hope you found it useful. Great. Well, I appreciate the poll results, and if there are any other things, feel free to reach out to me or to any of my colleagues. There's my email and Twitter, and this meetup group will be, getting some stuff started in the next, couple weeks here. Swap back here, just the letter C at StackRox.com. Okay, I'll stay here in case there are any other questions, but otherwise, I hope you have a great and yes, the recording will be sent to you. Zoom is a little bit slow these days because everyone is using it. So the videos will come a little bit later, but we'll get that out to you as soon as we have it. Okay, we'll go ahead and close the Zoom now. Thank you so much for joining us. We'll send that video out to you as soon as we have it. Have a great day.